Princesses and princes of pixels and legends of lighting, I'm Professor John Gallagher, and we've got another lesson on the world's most magical LED driver, the magnificent Pixelblaze. And in this lesson, we're going to learn how to connect multiple LED matrices and configure them so that they can run any Pixelblaze pattern. Now I'll show you how I set up and orient two 16x16 LED panels next to each other, but you should find the techniques that I describe here can be easily adapted for any set of LED panels. So in this lesson, after we connect our panels and set up Pixelblaze for more lights, I'm going to give you some code that you can run to show how your lights are wired together. Now this is likely different from the left to right, top to bottom pattern that Pixelblaze assumes, and since my LEDs are wired in my matrix panels in a pattern that's different than Pixelblaze wants, we're going to load up a test pattern that shows text scrolling across the panels. This is a great one to use when testing multiple panel mapping because if something isn't right, our lights won't properly scroll readable letters. And after that, I'm going to show you how we can load up the default multiple panel matrix mapper. We'll learn how things are set up by default, and we'll learn how we can change things to account for the pattern we notice in our lights. And when we're done, we'll have two panels acting as one. They'll work great on any pattern you might pull up, and you'll be ready for more unbridled light-up legendarity. So friends, let the path to awesomeness continue. And I say continue because if you're new here, welcome. But if you don't have your board set up and configured properly, you might want to head to the earlier lessons in our playlist to see how we got here. And be sure to check back. I use Pixelblaze in my physical computing course at Boston College that I teach every semester. That class is mostly CircuitPython, but we'll doubtless have more Pixelblaze lessons in the future. So here we are, and we're getting ready to work with multiple LED matrices. We'll add a second 16x16 panel to our project. So I'm going to unplug my project from power, then take the DIN of my second LED matrix and plug this into the DOUT, digital out, of the first LED matrix. Now just so you know, I'm powering from the auxiliary power from my first LED matrix. There'd be no problem if I wanted to put this on the second LED matrix instead. Now determining the best layout for these lights is always tough, so we might need to move things around, but I'll flip these over. And it shouldn't be surprising that our second set of LEDs isn't lighting up, because when we configured our Pixelblaze, we used only one LED matrix that has 256 lights. Now we've got 512. So let's change this. My students should be logged into the Boston College network, not EduRoam. Head to discover.electromage.com, access your board, and then let's head to the Settings tab. And we'll change the pixel setting to 512 because we have twice the LEDs that we had before. And what we're eventually going to want to do is to map the layout of lights on our LED matrices in a way that work with the Pixelblaze patterns. They don't match up. Now before we start, I want to grab a pattern called Scrolling Text Marquee 2D. It scrolls text across your patterns, and the reason I want to get this is it's great for testing to see if we set things up properly, because if we don't, we won't be able to read the message that should be scrolling by. Now, I didn't write this pattern. It was written by Jeff Viduna, so thanks very much for sharing your brilliance with us, Jeff. He's got a cool YouTube channel with lots of inspiring builds, so you can check that out. But I've put a modified version of this in a GitHub repo that you can find at this URL. So open a browser tab and head to github.com/.gallagher. Remember that's spelled like Gallagher, G-A-L-L-A-U-G-H-E-R, / all lowercase letters, Pixelblaze-patterns. Then click and hold on the green code button, and in the drop-down menu, select Download Zip. Find what you downloaded. It's probably in the Downloads folder. I saved mine to the desktop, and Safari automatically unzips, so I don't need to unzip it. When unzipped, the folder should be named Pixelblaze Patterns Main. If you look inside, you should see a file named Scrolling Text Marquee 2D.epe. That's the pattern we're going to import into Pixelblaze. Then in Pixelblaze, you can import the pattern like this. Head to the Edit tab, select Open File, navigate to the folder that you just downloaded. It's probably called Pixelblaze-patterns-main. Open up and find that file, Scrolling Text Marquee 2D. Select and open that. And on the right, you should see the word hack scrolling by, but our LED panels do not show that. So this suggests that our pixels on our LED display aren't mapping the way that Pixelblaze expects. Now I do want to save this pattern that I just imported, so click on Save New. And that saves this pattern. It should now be listed alphabetically in your list of patterns just on this Pixelblaze. So let's head to the Mapper tab to figure this out. Now we're eventually going to want to select multiple panel matrix, but first I want to verify how individual lights light up with the panels in their current orientation. So this is what I'm going to do. I'm going to pull down and select ring, then click Load Example, then click Save, and now we're going to write code to go through all of our LEDs, lighting them up one after another, and by watching the lights advance, you'll be able to tell the directional layout of the LEDs. For example, do lights light up from left to right, right to left, top to bottom, bottom to top, and do they restart every row or column, or do they move in a zigzag pattern? Now I said write code, we're actually going to copy and paste code. So head to the edit tab, click new pattern, and since you've mapped as a ring, you're going to see a ring of rainbow lights swirling on the right. And this is not what our lights look like, but if we tell our Pixelblaze that we're using a ring, it'll light up the LEDs one after another in the wiring pattern of the board. So let's get some code that I wrote for you. You can find it at this URL, bit.ly/pixelblaze-1. That's ONE dash at AT-A-time. So that's Pixelblaze one at a time with dashes between the words, all lowercase. And this opens up a GitHub gist. If you've not seen this before, it's just a place where you can conveniently drop in a bit of code. So you should highlight and copy all of this code, then return to the Pixelblaze editor in your browser and highlight the code that's in there. We don't want that. Paste the new code in to replace it, and you should see your LED light moving across the screen one pixel at a time. And if you've oriented your matrices like I did, and you've got the same matrices I did, and just to confirm, I have the JST wires in sort of the top third pointing down, and the first panel has the Pixelblaze attached to it, and it's oriented on the left of the second one, then these lights start in the upper left-hand corner, and they zigzag down and then up until it's gone all the way to the right. Then the lights start with the upper left-hand corner in the second panel, same zigzag pattern. And if you look at the code, it's likely very unfamiliar to my students who study CircuitPython. Pixelblaze in particular handles timing in a very strange way. You don't have the time.sleep function that we do in Python. But if you're curious, hopefully I've commented this code so that you can read it and understand it. You can ask AI to walk you through the code that you pasted in. That can sometimes be helpful. But really, you don't need to know how each line works in this code. Now, if you want to change the speed of the light moving forward, you can change the hold ems variable, which represents the number of milliseconds an LED light will be held lit. Lowering this value makes things faster, increasing it makes it run slower. And just to show you, you don't have to do this, but here are my same two matrices in the same orientation hooked up to a Raspberry Pi Pico running similar CircuitPython code. It's simpler to write than this Pixelblaze code. Now do know that Pixelblaze code will really excel if you start to write more complex LED patterns. And the light up pattern for the lights is exactly the same. That's what we expect. Turning the lights on one by one just shows how the lights are wired on our board. And if you ever work with a new set of lights and you want to access this Pixels one at a time test code, remember you can always get it online. So now that we know that our LED lights start lighting up in the upper left-hand corner and they moved down and then up in a zigzag pattern, we're ready to set up a mapping pattern so that the Pixelblaze can translate all of its patterns to the electronic layout of our lights. So let's head back to the Mapper tab, pull down the menu, and this time select Multiple Panel Matrix and click Load Example. Now you don't need to understand all this code here either, but we do want to understand a few things. Now there's a variable here labeled zigzag, and it's currently set to false, but we just showed that our panels do zigzag, so we want to switch this to true. And the other thing that's really important to know about is down here. Now we have a value called map. That's a JavaScript array, which is very similar to a Python list. Now the default here, when you load the example, always shows 4 values added to the map array. This actually assumes that we're using 4 panels. The concat statement adds a panel, so it's like appending an element to a list in Python. And it assumes these 4 panels are arranged in a 2 by 2 matrix grid, and each individual panel or matrix is a square 8 lights by 8 lights. Now that's not what I want. I've got 2 matrices, not 4, so I should only have 2 panel values that I concat into the map. My matrices are side by side, and each one of those is a 16 by 16 matrix, not an 8 by 8. So how do we change things? Well, if we look at our code, we can Sherlock out how each panel is created. You see, there's a function up here called panel, and it accepts 5 values or 5 parameters. And if we scroll up in our code, we can see that the panel function is defined, and the comments tell us what those parameters are: width, height, x offset, y offset, and any degrees of rotation. Okay, and you can follow along with me. You might be tempted to say, let's do this together. Let's delete 2 of these panels since we only have 2 panels, not 4. And we don't have 8 by 8 panels, we have 16 by 16, so we can change the width and height on both of these statements so that they're 16s instead of 8. And if our panels are side by side, our second panel should have an x offset of 16 here, not 8, because we should move a pixel over 16 lights to begin a line of lighting up lights on our second panel. Now this is close, but it won't work. And to show you this, and first let me go down here and save the pixel mapper so we can return to this work. But let's head to patterns and scroll down here and find the scrolling text marquee 2D that we just read in. And oh yeah, we can see this does not look the way that we expect. The letters aren't scrolling from one panel to another, they're rotated 90 degrees, the letters are backward, and they're scrolling from the wrong direction. So we got a little bit more work to do in Mapper, so click on the Mapper tab. And before we start that, let me show you a slide in animation illustrating the problem and what we need to do. So here's how our panels are lighting up. Starting in the upper left corner, zigzagging down, up, repeated. Now the challenge that we face is that the Pixelblaze assumes that the coordinate system moves like this. See up here? Still starting in the upper left-hand corner and zigzagging, but left to right, not down and up. So how do we fix this? Well, first we're going to rotate our panel, and we do that by changing the rotation parameter. That's the last input in the panel function. 90 degrees will start off in the lower left and turn the lights on in this orientation. 180 degrees will start in the lower right, but 270 degrees is getting closer. This gives us a zigzag pattern, but we start in the upper right and move left, and we want to flip this to start in the upper left and move right. Now before we get to the flip, what about if we add a second panel? Well, we've positioned it to the right of our other panel with this orientation, and we're going to want to shift any lights over by 16 lights, because if we start over here at position 15, 0, we want to be over here on this panel at position 31, 0. So any light that we light up over here, we're going to have the second panel equivalent by adding 16 to the X value. That means our X offset parameter is 16, there's no change in the Y offset. Now I could add my statement for my second panel under this one, but instead I've added the second panel's map statement ahead of this first panel. So what I've got is almost what I want, except this orientation where I start in the upper right and move left is the exact horizontal flip of what I really want to be in the upper left and move right. Now how do I flip things? Well, I have to add a little bit more code for that. Now you don't have to memorize this, just know that if you want to flip the orientation of your panels, you can reuse this code wherever you need to. The only thing that you might need to change is the width. Ours is 32 because we have two 16 by 16 LED matrices side by side. So what this code does is it goes through every row and it flips the orientation horizontally. Map I is actually a pair of values inside of map I, X and Y, kind of like a tuple in Python. So map I in bracket 0 will give us the first value of XY, which is X. And this line of code here subtracts the panel width by the current X value of the light. So if we add this code to our map setup, our panel map that starts in the upper right of the second panel and moves left will be flipped over mirror style horizontally so that we start in the far left and zigzag to the right. That's what Pixelblaze wants. Woohoo! So now let's enter this code in our mapper and see if this works. Now I'll flip everything 270 degrees, so I'll make 270 the last parameter in both of these panel statements. I'm going to move the bottom line where we create our second map panel and have an X offset of 16, and I'll cut it out from below and paste it in front of the first one. And now if you look over at the text scrolling on your panel, you might say, gadzooks, things are backwards. Well, that's exactly why we need our flip code. So just below these two map statements, we're going to write code that says var all caps total underscore width equals 32 colon. We've just created a variable called total width, which holds the total width of both of our panels side by side, which is 32. And I'll put in a double slash comment that says, this sets the width of the two matrices side by side. Change this if you have a different setup. Then we'll write a for loop. The syntax is a little bit different than Python, but it should be familiar. We're going to say for, and then inside parentheses, var I equals 0, colon, that means start at 0. And be careful, it looks like code completion put various in here instead of var. You want var to create a variable. So correct that var I equals 0, colon, then continue on that same line with I less than map.length, colon. That means stop just before you get to map length, which is map length minus 1. And I++ is your increment value. We're going to increment by 1. Then open curly brace, close curly brace below this, and I'll put in another comment that says this is just a loop that goes from 0 through the map length minus 1. And I just noticed code completion put 16 in here instead of 1. It should be 1 in the comment. And the calculation we want below this is map in between square brackets I. This pulls out a coordinate, which is x comma y. Then right next to this, we're going to say between square brackets 0. That's going to be the first value. Remember, computers start counting at 0, so 0 and 1 are the first two values, which is the x value. And we're going to set this equal to, in between parentheses, total underscore width minus 1. Then outside the closing parenthesis, we're going to subtract map in brackets I in brackets 0, colon. What does that do? Well, I'll put a comment in here that says it flips x. And code completion screwed up my comment again. This should be x, not x2. We got the closed curly brace below this, and my friends, look at this magnificent. The LED matrices now say hack. Now before we forget, let's click Save so that the map pattern is saved. But do know if you enter the Mapping tab and select Multiple Panel Matrix again, then load Example, you're going to have to recreate this. Now if you need code for this, I've included it in a link in the description. But now that we've got everything set up, let's head over to our patterns and we can try out a few other 2D patterns. Does Spotlight look like the light moving smoothly across two panels? Indeed it does. And how about Spiral Twirl? Yep, it's properly centered. The pinwheel is in between the two panels. Indeed, Code Monster, your work mission is accomplished. Feel free to go ahead and try other patterns. Your multiple matrices should indeed be looking fabulous. Maker, revel in the rapidly accruing skills, for you have indeed made something awesome. Be sure to come back for more goodness, but until then, continue to hack.